My name is Carlos Mendez. This is my video project for Mr. Donald Johnson's Fundamentals of Physics online course from Full Sail University. As a web design and development student, the internet will be the architecture that I will rely on and design for during my career. For my video project, I have chosen to focus on the implications of electromagnetic radiation and how its fundamental principles are ultimately responsible for the developments that led to the technologies that make up today's internet. I hope you enjoy the presentation. During our overview of physics, we were introduced to a number of subatomic particles: protons, electrons, neutrons, and the most versatile, marvelous, and fastest of them all, the photon, the fastest particle in the universe. The photon, first identified as a particle and named by physicists in the early 20th century, is the basic unit, or quantum, of electromagnetic radiation, and propagates throughout the universe at speeds up to and even beyond the theoretical speed of light. Medium energy photons are called light, or light waves, those frequencies that are perceivable by the human eye, and high energy photons are called X-rays, while those having even higher energy still are called gamma rays. The physics of electromagnetic radiation has been studied since the late 1800s and has given rise to prominent technologies such as radio, which was first experimentally demonstrated through the transmission and radiation of radio frequency energy, or radio waves, in 1892 by Nikola Tesla. In its early days, radio was only capable of transmitting signals as far as 1.5 miles, but in 1900, Reginald Fessenden made the first weak transmission of voice over the airwaves. Later, through the development and use of more sophisticated electronics, such as the vacuum tube, high-fidelity voice transmissions became possible. Radar, while in its developmental infancy during World War II, initially used vacuum tubes as signal amplifiers and was able to provide early warning of German air raids to the Allied forces fighting in England. Research in radar and related fields by American and English physicists during and after the war ultimately led to the development of the transistor and the birth of the semiconductor industry in the late 1950s. Some say this was the most significant technological development of the 20th century. Interestingly enough, the same principles of signal amplification used in radar are also used to pop microwave popcorn in thousands of modern households every day. In fact, the first commercially available microwave oven was called the Amana Radar Range. And while early electronic computers used vacuum tubes for their circuits, the continued development of the transistor eventually led to the integrated circuit, the heart of a modern computer, which we as students of Full Sail University all use on a daily basis. The modern computer is the cornerstone of our creative endeavors, as well as in so many other activities we engage in without even giving much thought to it. While transistors function on the most basic level, either as a switch or an amplifier through which the movement of electrons is controlled in the form of electric current, some transistors are capable, through amplification, not necessarily in power, but in frequency, of converting those electronic signals into visible light, which can then be used to do many very interesting things. For instance, a very specialized form of transistor is known as an LED, or light-emitting diode. The LED was the forerunner to the laser diode. Laser, an acronym which stands for Light Amplification by Stimulated Emission of Radiation, is a piece of modern technology which had its theoretical foundations laid by Albert Einstein in a paper he published in 1917, based on a derivation of Max Planck's law of radiation. Conceptually based upon probability coefficients for the absorption, spontaneous emission, and stimulated emission of electromagnetic radiation, the first functional laser was operated in 1960 in Malibu, California. The laser diode, in the case of fiber optic networks, can receive electronic signals and convert them to pulses of light to be transmitted over an optical fiber to carry data or voice traffic. This transmission technology is the primary method used in the backbone of the Internet. A massive infrastructure of routers and switches connected by fiber optic cables, forming the information superhighway responsible for moving large quantities of data around the planet daily. According to data provided by the Minnesota Internet Traffic Studies, in the year 2011, U.S. Internet backbone traffic was between 3.4 and 4.1 million terabytes. Yes, it's true. The Internet, a massive, worldwide electronic data network, is inextricably linked to the physics of the photon, the fastest particle in the